Today, I'm going to introduce the project chosen by our group. This project combines CPS with AR and VR to create an immersive learning platform, thereby addressing some of the issues currently present in online learning. First, it is necessary to introduce the problem background of this project. In today's society, with the development of technology, the content that students learn has become more diverse. However, the traditional classroom learning and educational methods can no longer meet the learning requirements of students in today's society. At the same time, as we all know, during the COVID-19, many schools choose online platforms as their daily teaching method. However, the current online platforms cannot replace traditional classroom learning and have many problems. We believe that there are many the following problems. The first one is that when students use online platforms to learn, they cannot conduct actual experiments. They can only learn by watching videos. The second one is that the interaction between students and teachers is very scarce, which makes students less about learning and prone to distraction. Third point is that the intelligent management level in school is very low, which leads to problems such as difficulty in managing students and low learning efficiency. So these problems will cause many impacts. I have given some examples in this slide. In generally, the current online model prevents students from conducting actual experiments, lacks interactivity, and is inconvenient to manage. This had a lot of negative effects on students' learning efficiency, learning interest, and the daily management of the school. Therefore, to address these issues, our project has proposed to the following three objects. The first one is combine CPS with AR and VR, enable students to conduct virtual experiments on this platform. The second is develop a real-time collaborative system that supports multi-users. And the third one is build an extensible CPS architecture model for education. So in this project, we mainly combine AR and VR technology with CPS to create a brand new teaching platform. We will use VR for experimental simulation, providing a 3D interactive experimental platform. Meanwhile, we will also use VR for experimental systems and enable multiple students to conduct joint experiments, discussions, and operations in a virtual collaborative space. We will develop it using technologies such as Unity and WebXR, supporting cross-platforms operation on devices like PC and VR headsets. Besides besides AR and VR technologies, we will also adopt technologies like 5G to ensure high speed and low latency network and use cloud computing technology for field management.
Then is the system architecture. We divide the system into five components, including users, clients, edge nodes, physical classroom, and cloud server. Next, I will briefly explain the interaction of the components. The user's operation data is transmitted from the client to the edge node and then to the cloud. The client will then render the data returned by the cloud to achieve dynamic feedback. The sensor data of the physical device interacts with the edge node and the cloud through the gateway. Next is the creativity of hyper-learning CPS. We summarize it into 3 points. The first point is seamless integration of virtual and the real world. The system breaks through the boundary between physical classroom and remote learning by using real-time digital technology to project physical devices. This allows students from different regions and learning environments to learn together in a virtual environment. The second point is democratization of immersive education. The system could support multi-terminal access, like AR, VR, PC, and tablets, and achieves smooth operation of low-end devices through dynamic degradation rendering technology. Through users' authentication, different UIs can be designed for different users. The last point is each cloud's collaborative intelligence. Each node handle real-time sensor data synchronization with high requirements and manage global status in the cloud. Then comes the innovativeness. As you can see from this slide, traditional classrooms are limited by physical space. Even large lecture hall can only hold about 100 students. Expanding capacity is expensive and not flexible. In hybrid learning CPS, all of these changes. With cloud-based infrastructure, it can host hundreds or even thousands of students in a single virtual environment. And scaling is as simple as adjusting server resource. Also, in traditional classrooms, physical teaching tools like lab equipment are expensive and often limited. But in hybrid learning CPS, students can access highly realistic virtual labs using AR and or VR. This means more access, more practice, and lower cost. Now let's look at traditional remote learning. These are mostly 2D videos, like live or recorded. The learning is passive, with limited interaction. Students just sit and watch. But hybrid learning CPS goes much further. It can support multi-devices access, including AR, VR, and PC. Students are placed in fully immersive virtual classroom or labs, which make them feel like being there in person. Interaction is also a major upgrade. Instead of just typing in chat, students can move, speak, react, and collaborate in real time. And for hands-on learning, it offers full simulation-based practice environments. So students don't just watch, they can do.
There are four reasons why this system relevant for future educations. First is this platform builds a virtual real integrated learning environment through the integration of CPS and AR/VR technologies, which is the key supplement to the future education model. And the second reason is compared with the traditional online teaching. This platform offers immersive, operable teaching scenarios and meeting the needs of cultivating higher order thinking abilities. The third reason is this platform breaks through the limitations of time, space, physical increment and enabling students in remote areas or international students to access advanced teaching content and experimental facilities through this digital platform. And the last reason is this platform's architecture supports multiple terminals, multiple disciplines, and multiple teaching methods, and leaving enough interface and space for the future development of personalized learning, intelligent teaching, and AI assisted teaching. Okay, and this page shows the benefits to student and faculty. To student, improvement of practical ability. Experimental operations can be completed in a virtual environment, making up for the shortcoming of traditional online teaching that lacks a hands-on link and provide opportunities for repetitive practice to enhance skills proficiency and learning tolerance. And it also enhance and the second is enhance the immersion and sense of participation. AR/VR simulators real scenarios to enhance students' attention and participation, support real-time interaction to enhance a sense of belonging. The last is the fair access to educational resource. This platform solves the problem that students in remote areas have no access to its experimental teaching resource and achieve equal educational opportunities. And the benefits to faculties are three aspects. The first is the diversified teaching methods. So, this platform supports modern teaching methods such as virtual demonstrations, immediate feedback, and dynamic evolutions. The second is the improvement of teaching efficiency. Multi-person collaborative operation and the management tools reduce teachers' repetitive work. It can achieve same class teaching in different locations and expanding the influence of teaching. And last is reduce the consumption of teaching resource. This platform reduces the wear and tear and maintenance pressure on real increment, and no destructive experiments can be conducted on the virtual platform. There are two benefits to institutions. First, this platform realizes the digital and intelligent management of increment, reuse, and teaching activities. And this platform reduces the cost and improve the efficiency and security of operation and maintenance. The second reason is this platform maximize the resource utilizations. Uh, High simulation and virtual libraries and multi-terminal sites have expanded educational capacity and resource reuse. They avoid the idleness and repeated investment of expensive experimental equipment.